length is based on the distance formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And they define what's called a rectifiable curve. A rectifiable curve is just one that has finite length. Do you know what finite means? It ends. It has a definite length, okay? A rectifiable curve is something that has a definite arc length. And it just, to be a rectifiable curve, it has to, just has to be continuous and smooth. So basically what we would want to do, just in general, is we would want to take, let's say we've got this curve right here, and we would like to find the length of this curve from right here, x sub 0, to some other x sub n value. And so we're looking for this entire length. So, if I were to just find the distance between these 2 points, would that distance be a good estimation of the length of that curve? No, that'd be really bad. Okay? So basically all we do is we break this up into as small a sections as we can. So really all we want to do is kind of break this up. If I found that distance from there to there, and that distance from there to there, and then that distance from there to there, if I just broke it up into little tiny sections and found the distance between each of those points and added them up, would that be a much better way of finding the length of that curve? Yeah. So basically all we're doing, just in general, and they walk through very detailed steps of how they come up with the formula, if you'd like to try to follow that. But the idea is that we just take, basically we want these distances, the distance between these 2 points to become 0. We want to basically add up an infinite number of little distances. We want them basically to be the length of a point. And if we actually do that, then we'll get the actual length of the curve. So really all we're doing is we're repeatedly using this distance formula. Now, the distance formula, well, they do. I don't think you need to know that. So anyways, that's just the basic idea. Okay, we're just finding a bunch of little distances and adding them up. Okay, it's not probably necessary that you know the whole proof of everything, but the formula that you need for the arc length, so this is the definition of arc length. The main thing you need to know is that the arc length formula comes from the distance formula in geometry. Okay? Just like the volume of a surface of revolution comes from the formula for the volume of a cylinder. Okay, in geometry. All right, so definition of arc length. Arc length, let y be a function given by y equals f of x. Y equals f of x is a smooth curve on the interval from A to B. Then the arc length, which is called S. S is arc length, which was actually the same arc thing that you used in pre-calc when you talked about arc length. S, little s, is equal to the integral from A to B of the square root of 1 plus f prime of x squared dx. Similarly, if x equals g of y is a smooth curve on the interval from c to d, then the arc length would be the integral from c to d of the square root of 1 plus g prime of y squared dx. So this would be like with respect to the x and with respect to the y axis. Thank you. That should be dy. All right, so the length of we're just going to start with something really easy. The length of a line segment. And on the first few problems, I'm going to ask you to fully work out the integral. Yes, you're going to have to not use the integration capabilities of your calculator on the first few problems. You can use them to double check your answer, but I would ask that you work through the process because it's good algebra practice. Okay, so we're going to look at like 2 examples here for the length of a line segment and arc length. Thank you very much. All right, so first thing, length of a line segment. So let's say I want to find the length of the line segment between, someone give me an ordered pair. 2, 4? Okay, someone give me another ordered pair. 1, 3? Okay, that's better. 1,000, 5 would have been a good one. Should we use that one? Okay, let's use that one. Yeah, I like that one. All right, so we want to find the length of this line segment, and could we just use the distance formula? Yeah, we could, but we're going to use integration instead because it's more fun. Okay, so it says to find the length of a line segment, we are going to use this formula. The integral from a to b of the square root of 1 plus f prime of x squared dx. All right, well, how's that going to help us? What? It's close. It's not from 1,000 to 2. It's from, well, it's not the same thing. What goes on the bottom? 2 to 1,000. Good. Okay. So we'd be integrating from the beginning x value to the ending x value. All right. Now, here's where remembering something I told you in calculus is going to become helpful. What is this right there? Just in general, what is that? What is that? What does derivative mean? Slope. So this is the slope squared. Can you find the slope between those 2 points? Yeah. So it's going to be 1 plus y minus y, 5 minus 4, over x minus x squared. All right, so it's not too bad. 5 minus 4 is 1 over 998 squared. Okay, so how am I going to kind of simplify what's underneath here? Well, 1 squared is 1, 998 squared would be on the bottom here. If I wanted to get a common denominator with this 1, how would I write it? 998 squared over 998 squared. Okay, so then under the radical you'd have whatever 998 squared plus 1 is over 998 squared. Notice I'm not too worried about pulling out a calculator quite yet. Alright, so when you're taking the square root of a fraction, can't you square root the top and bottom separately? So what's the square root of the bottom? 998. And then the top is not going to be that fun. I'm just going to kind of leave it like that. Okay, so have we simplified our radical part as much as we can? Yeah, as much as I want to. I don't want to get a calculator out yet. So what is the antiderivative of that mess? Describe that for me. It's a number. What's the antiderivative of a number? Number times x, right? So I'm going to have that number, and I need to evaluate 998x, and I need to evaluate it between 2 and 1,000. So you're going to put 1,000 in, and then you're going to put 2 in, and then you're going to subtract those. My calculator's missing, so. Alright, so our formula for arc length, S is the integral from a to b of the square root of 1 plus f prime of x squared dx. Alright, so what are we going to need to do with this function? Okay, we're going to take its derivative. So y prime is going to be 5x to the 4th over 10. And then I'm going to have to write this as 1/6 x to the negative 3. 1/6 x to the negative 3. Multiply by negative 3, which makes it negative 1/2 in front. Subtract 1, puts an x to the 4th on the bottom. So what's one more thing that I can do with that before I say there's my final derivative? Simplify. What are we going to simplify? 5 over 10 becomes 1 over 2. So there's my derivative. Now I'm just going to plug it in. What are my limits of integration? Okay, from 1 to 2 of the square root of 1 plus x to the 4th over 2 minus 1 over 2x to the 4th squared dx. Alright, now we can work this out by hand. In your first few problems you will need to show all the steps and work this out. And then for most of your homework you'll be able to plug it in to your calculator. Alright, so we can evaluate this integral, but what we have to do is we have to basically come up with something under here. We have to simplify this. Okay, so all we're going to do is FOIL this out. So the first thing I'm going to do is FOIL that out. It's still all under the radical.